Imagine making like massive company-shifting business decisions. I'm talking allocating hundreds of thousands, maybe millions of dollars in marketing budget.
Right.
And you're doing all of that based on data that is mostly just your own team, clicking around the website.
Oh, yeah. It happens all the time.
I mean, imagine the CEO popping champagne because user engagement is up 300% this quarter. But the reality is, it's just Bob from the QA department testing a new web form over and over again.
Yeah, you might be celebrating a total mirage.
Exactly.
Yeah.
Welcome to Fix the Funnel with GA4. I am so thrilled to kick off episode number 20 of our series. Today we are embarking on a deep dive into mastering GA4 data integrity.
Which is such a crucial topic.
It really is. We're going to figure out how to stop your internal traffic from quietly destroying the accuracy of your analytics.
Because it is a terrifying scenario. And frankly, it's a much more common reality than most executives want to admit,
Oh, absolutely.
If you're operating on polluted data, every single downstream decision is compromised. You're effectively flying blind. So in this deep dive, we're going to dismantle the mechanics of how this pollution happens.
Right, because GA4 processes IP data way differently than the legacy systems did.
Exactly. And we'll go over the precise, layered steps you need to take to sanitize your analytics environment for good.
Okay, let's unpack this, because before we get into the technical architecture of GA4, we need to understand the sheer scale of the problem.
Yeah, the hidden pollution in your analytics.
Right. Industry benchmarks show a staggering statistic. Internal traffic, which includes like your developers' testing staging environments.
Or repeated visits from the sales team pulling up resources.
Exactly. Or the QA department running automated scripts. All of that can account for 10 to 30% of total website sessions.
Yeah.
30%. That is an enormous chunk of data. It's like trying to count the number of genuine customers in a retail store, but you're accidentally counting the staff restocking the shelves every 5 minutes.
That is the perfect way to look at it. And what's fascinating here is how quietly this 10 to 30% distorts the foundational metrics of a business.
Right.
When you fail to exclude that internal behavior, you are no longer analyzing a real user journey. You're just analyzing operational noise.
And the casualties of that noise are pretty severe.
Oh, incredibly severe. Just think about your conversion rates. If your internal team is constantly triggering actions, like filling out lead forms to test them, or clicking through checkout flows to verify payment gateways,
your conversion rates are going to look artificially high.
Exactly. You look at the dashboard and think your funnel is performing brilliantly, but it's really just your developers doing their daily job.
But wait, doesn't that create a really dangerous domino effect? Because if your conversion rates look artificially high and your overall session counts are inflated by your staff.
Your customer acquisition cost is going to look artificially low.
Right, your CACs. You're taking your marketing spend and dividing it by a falsely high number of quote-unquote acquisitions.
Which is a disaster.
Yeah, I mean, a marketing manager might look at a CAC of $20 and think, wow, our ad campaigns are killing it. Let's double the ad spend right now.
Meanwhile, the actual CAC for genuine paying outside customers might be closer to $50 or $60.
Exactly. And that is how you burn through a quarterly budget with zero real return.
Yeah, and it completely overstates your return on ad spend too, your ROAS. And this gets even worse if internal traffic or, traffic from your partner agencies ends up mimicking genuine conversions.
No, wow. Yeah.
Furthermore, consider the impact on your A/B tests.
Oh, right.
You might be running a sophisticated test on a new landing page, but if 20% of the traffic hitting that page consists of your own employees...
People who already know exactly how the product works.
Exactly. They know where every button is. Their behavior does not reflect a new user's experience. They have institutional knowledge, so they don't read the copy. They just click through.
So your test results become entirely unreliable.
Precisely.
And then your attribution data gets skewed too, right? You start crediting all this internal high-intent activity to your paid or organic channels.
Yeah, it's basic causality. Bad inputs inevitably create bad outputs.
So executive decisions based on this data aren't just slightly off. They are pointed in the completely wrong direction.
100%.
So why is this certainly such a massive headache for teams? I mean, let's look at how Google Analytics 4 handles IP addresses compared to the old Universal Analytics.
Right, the old system.
Yeah, the Universal Analytics, you just set up a simple view filter, typed in your office IP, and you were done.
It was very straightforward back then. But GA4 completely re-engineered this process into a two-step architecture.
Okay, break that down for us.
So first, GA4 evaluates incoming IP addresses at the data stream level. If an IP matches your defined rule, GA4 assigns a hidden parameter to that session.
Like a tag.
Exactly. It's called traffic_type equals internal.
Wait, so GA4 labels the bad data, but by default, it doesn't actually take it out of my reports. It's like putting a sticky note on a bad apple but leaving it in the fruit bowl.
That is a brilliant analogy.
Yeah.
Yes, tagging alone does not clean the data.
That's crazy.
It is. GA4 intentionally separates the identification of internal traffic from the actual filtration of it. So when an event comes in, GA4 checks it against your IP rules. If it matches, the event gets a sticky note.
Right.
But if you stop there, which shockingly a massive percentage of teams do, that tagged traffic is still sitting right there in your standard user acquisition reports, just inflating your numbers.
So to actually remove the bad apple from the bowl, you have to apply a data filter at the property level.
Exactly.
That seems like a massive design flaw. I mean, why wouldn't Google just filter it out automatically once you define the rule? It feels like they're just setting a trap for marketing teams who don't have deep technical backgrounds.
Well, it feels like a trap, yeah, but it's actually designed for data safety.
How so?
Google separated these steps because data filters in GA4 are destructive. Once data is filtered out, it is permanently deleted from your servers.
Oh.
Yeah. By separating the tagging from the filtering, Google is giving you a chance to verify your rules before you accidentally delete legitimate customer data.
Okay, that makes sense.
However, the friction really comes from permissions, because only users with editor-level access or above can configure these property-level data filters.
Right, which limits who can even spot the misconfiguration, let alone fix it.
Exactly. A marketing manager might look at the data stream settings, see that internal IP rules are defined, and just assume the data is perfectly clean.
But if that second step, the property-level data filter, is missing,
Yeah.
the entire data set remains fully compromised.
Precisely.
That is wild. It's a total false sense of security. You think you're protected, but the front door is wide open.
Right.
So let's give you, the listener, the tactical solution for a standard office environment. Like if you are operating with an on-premise team or you have a fixed headquarters, this is your immediate path to sanity.
The 10-minute fix.
Yeah. Step 1, find your public IPv4 address. You can literally just go to Google, type, "What is my IP?" and copy that string of numbers.
Super easy.
Then you go into the GA4 admin panel, navigate to data streams, select your web stream, click Configure Tag Settings, and then click Define Internal Traffic.
And precision here is critical. When you create a rule, name it descriptively. Don't just call it office.
Right, because you'll forget which one that is.
Exactly.
Right.
Call it HQ_office, followed by the actual IP address, or London_agency_IP. A year from now, you need to know exactly what that rule is evaluating.
Good point.
Then you set the traffic type parameter to internal and set the match type to IP address equals. And if you have multiple offices, you just use the add condition button to evaluate them with OR logic.
But what about IPv6? You know, those longer, infinitely more complex IP addresses. A lot of modern corporate networks use them now.
Yes, they do.
If your network uses ITC6, just typing in your old IPv4 address isn't going to catch anything, is it?
No, it won't catch a thing. IPv6 addresses are alphanumeric and much longer, looking something like 2001:DB8::, followed by more blocks.
Yeah, they're a mess to read.
Totally. So if your corporate network routes traffic through IPv6, you have to document those ranges with your IT department.
Right.
You might need separate rules, or you might need to use regular expressions, regex, to match the start of the IPv6 block, like $2001:DB8::/32, just to make sure you're catching the entire office network.
So what does this all mean? I mean, we've defined the rules, we put the sticky notes on the apples, now we have to actually build the filter to take them out of the bowl.
Precisely. Step 2 is navigating to data settings in your property, then data filters. You'll find a default internal traffic filter waiting there.
Okay.
Now here is a critical mechanism you must understand. Filter states. You do not switch this filter to active immediately.
You don't.
No. You set the filter state to testing first.
But why the testing phase? If I know the IP address is definitely my office, why not just flip the switch and clean the data right now?
Because, as we touched on earlier, data filters in GA4 are forward-looking only, and their effects are permanent.
Oh, right. The destructive part.
Exactly. They do not clean historical data. They only apply to data arriving from the moment you hit Save Onward. When you switch a filter to active, Any data that matches your rule is permanently dropped before it ever reaches your standard reports.
It's just gone.
Gone forever. So let's say you made a tiny typo in your IP rule and accidentally matched the IP block of your biggest enterprise client.
Oh, no.
Yeah. If the filter is active, you cannot get that client's data back. Ever. By leaving it in testing for 24 to 48 hours, the data is tagged as internal, but it's still visible in the interface.
Okay, so you can check it.
Right. You go into an exploration report, pull up the dimension for test data filter name, and verify that only your actual office traffic is carrying that tag before you pull the trigger.
That is a massive warning. Once it's filtered, it's vaporized. And you also have to be patient with the testing phase, right? Because GA4 doesn't process data in real time like the old Universal Analytics did.
Oh, not at all.
GA4 processes events in micro batches. So it can take like 24 to 36 hours before those filtered events actually settle and disappear from your standard reports once you do go active.
Yes.
You can't just flip the switch at 9 a.m. and expect the dashboard to look perfectly clean by lunch.
Correct. It requires a methodical, patient approach. You test, you verify in explorations, you wait, and then you activate.
But even if you do all of that perfectly, there is a massive complication looming over this entire strategy.
Oh, yeah. The remote reality.
Exactly.
Yeah.
The 10-minute IP fix is great for a traditional office, but when IP rules fall short, they fall short hard. Because of how we actually work today, the simple IP method just isn't enough anymore.
Right. And this raises an important question. What happens to your data integrity when there is no office? Current industry data indicates that by 2026, 40 to 60% of internal corporate traffic will bypass IP filters entirely.
60%. That completely undermines the IP filtering strategy.
Yeah.
Why is that bypass rate so incredibly high?
Because the modern workforce is untethered. I mean, employees are working from home using dynamic residential IPs that their internet service providers rotate every few days.
Right, or they're working from coffee shops on public Wi-Fi.
Exactly. Or they're tethering to 5G mobile networks while traveling. Even if they are using a corporate VPN, modern VPNs often use rotating exit nodes for security, meaning the IP address changes constantly.
Wow.
An IP address is essentially a geographic anchor, but your workforce is no longer anchored.
So the IP filter is really just catching the people who physically scan a badge at the headquarters. Meanwhile, the entire remote sales team and distributed engineering team are still flooding the analytics with noise.
Exactly.
We need alternatives. And the technical discussions on this point outline a couple of major strategies to catch remote workers.
Yeah, there are two main ones.
Right. Strategy A is using data layer flags. This sounds a bit more developer heavy. This is where your engineers push a specific parameter like user_type equals internal into the website's data layer the exact moment an employee logs into the company system or the SaaS product.
Yes.
Then Google Tag Manager reads that flag and overrides the traffic type to internal, completely ignoring whatever random coffee shop IP the employee happens to be using.
It is a very elegant solution, specifically for authenticated environments. If your product requires a login, like a SaaS platform or a secure employee portal, you catch them every single time they authenticate.
That makes sense.
Now, strategy B is less developer dependent. It involves using cookie or URL parameters.
Okay.
You give your remote team a specific bookmarkable link to click. Say yourwebsite.com/internal_user equals true.
Got it.
When they visit that specific link, it triggers a script that sets a first-party cookie in their browser. From then on, Google Tag Manager reads that cookie on every page view and flags all their subsequent activity as internal.
Okay, I see the utility in that, but I have to push back hard on strategy B.
Go ahead.
What happens when Jane from marketing decides to clear her browser cache and deletes that cookie? Or what if she uses an incognito window to test a new landing page?
Right.
Or even simpler, what if an engineer is just browsing the public company blog before they actually log into the secure SaaS platform? Doesn't this entire cookie and data layer setup quietly fall apart in all of those very normal scenarios?
You've hit on the exact vulnerability of these methods. Yes, it absolutely falls apart. Cookies get cleared routinely.
Yeah, all the time.
Privacy-focused browsers and Apple's Intelligent Tracking Prevention, or ITP, actively block or expire cookies. And pre-logging behavior on your public marketing site remains completely untracked by the data layer method because the user hasn't authenticated yet.
So neither method actually works perfectly on its own.
Exactly. This is why relying on just one of these methods creates a massive blind spot. Real-world, robust analytics setups must combine IP filtering with these alternative methods.
You have to layer them.
You layer your defenses, yes. You use IP filters as the unbreakable baseline for your fixed offices and static VPNs. You use data layer flags to catch authenticated sessions for remote workers logged into the app.
Right.
And you perhaps use cookie marking for remote freelancers or external agency partners who don't have login credentials but need to review the public site. If you rely on just one single mechanism, you are guaranteed to be either undercounting or overcounting your internal traffic.
It's like securing a physical building.
Right,
You don't just put a padlock on the front door and call it a day.
right.
You have the lock, you have the alarm system, you have the motion sensors, and you have the cameras. You layer the defenses because any single point of failure will eventually be breached.
It's exactly it.
But, even if you layer your defenses perfectly with cookies, data layers, and IP addresses, the system isn't bulletproof. What happens 6 months down the line? Because analytics architecture isn't concrete, it's software code.
Oh, absolutely.
And just like software accumulates technical debt, your filters accumulate exclusion debt over time. Let's look at how this system degrades.
If we connect this to the bigger picture, maintenance is where most companies completely fail.
Really?
Oh, yeah. Let's look at the operational realities. 40% of GA4 properties define their IP rules but never actually activate the property-level filter.
Wow. So they do the sticky note part but never take the apple out of the bowl.
Exactly. And this single oversight inflates their sessions by 10 to 20% indefinitely.
That's wild.
Another 25% of teams actually get to the filter stage, but they leave it in testing mode for months, assuming the data is clean just because they clicked through the setup wizard.
And what about the remote QA teams we talked about earlier?
Yeah.
I saw a case study recently about a mid-sized SaaS company that found their churn rate reports were artificially inflated by 15%.
That is math.
15%.
Yeah.
Just because they didn't filter out the external QA vendors who were constantly creating dummy accounts, testing the onboarding flow, and then canceling those accounts.
Yeah.
That is the kind of massive metric distortion that gets people fired or causes venture capital investors to pull out during a board meeting.
And it is entirely preventable with proper maintenance. Another silent killer of data integrity is simply the passage of time and corporate IT changes.
Like what?
Well, 20% of offices change their internet service providers, update their VPN configurations, or move physical locations every single year.
Oh, right.
If your IT department changes the provider over a weekend, your office gets a brand new block of IP addresses. Suddenly, on Monday morning, GA4 thinks you have a massive, unprecedented surge in new external traffic, when it's really just your own staff arriving at work, drinking coffee, and opening the company homepage.
Here's where it gets really interesting, though. And by interesting, I mean catastrophic. Let's talk about the danger of regular expressions or rejects.
Oh, rejects.
Let's say a well-meaning marketing op tries to be clever and writes a rejects rule to block 192.168.* to try and catch all local network traffic across all employee homes.
That's a classic mistake.
Right. But because it's a poorly scoped rejects, it accidentally matches the home Wi-Fi networks of actual paying customers who happen to use default router IPs. I've read reports stating this specific mistake can accidentally drop 5 to 10% of legitimate revenue attribution.
Wow.
You are literally erasing 10% of your company's actual revenue from your own reports because of a typo in a text box.
That perfectly illustrates the destructive, unforgiving nature of an active data filter. You cannot unring that bell.
Yeah.
This is why enterprise teams, specifically those piping their GA4 data into Google BigQuery, have to implement automated validation methods. You cannot rely on human memory to check these filters.
So what do they do?
One highly effective method is calculating what data engineers call a leak rate.
Okay, break that down for us. I'm not a SQL engineer. What exactly is a leak rate, and how does it protect the data?
Well, in BigQuery, you have access to the raw event-level data from GA4. You can write an automated SQL query that counts the number of events tagged with the parameter traffic underscore type equals internal, and divides that by the total number of events for the day.
Okay.
The formula is essentially count of traffic underscore type equals internal divided by the count of all traffic. That fraction gives you your leak rate.
Wait, but if your data filters are working properly in the GA4 interface, that internal traffic shouldn't be making it into the final BigQuery export at all, right? The active filter should have destroyed it.
Exactly. So in a perfectly functioning system, your leak rate in BigQuery should be 0.
Ah, I see.
If your leak rate suddenly exceeds a tiny threshold, say 0.01 or 1% on any given day, it triggers an automated Slack or email alert to the analytics team.
Isn't a 1% leak rate too tight of a threshold for a massive enterprise?
It is tight, but it has to be. If it hits 1%, it means your property level filters have failed, or perhaps someone deactivated them by accident.
Or, more likely, a new, untracked internal IP block has shown up.
Exactly. And internal data is suddenly leaking into your pristine data set. It allows you to catch the degradation in hours rather than months.
It's like an automated tripwire for your data integrity.
Mm.
Really like that approach. But there's also an alternative strategy we should touch on for teams who don't want to rely on destructive filters at all.
Yes, the sandbox method.
Because what if you actually want to see your internal traffic? Say the product team wants to analyze how the QA team is interacting with a new dashboard to debug the user experience. You can't do that if you've permanently vaporized the QA data with an active filter.
You cannot. So for teams that need to study internal behavior, the strategy is to send internal traffic to a completely separate GA4 property. You don't use GA4's internal traffic filters at all.
Okay.
Instead, you use Google Tag Manager to split the flow at the very source. You set up a routing variable. If a user's IP matches the office or they have the internal cookie, send their event data to GA4 property B, which is the sandbox.
Right.
If they are a normal customer, send the data to GA4 property A.
Okay, the pros of that are obvious. Your main property stays perfectly clean without needing complex destructive filters, and you get a dedicated sandbox property to analyze your internal UX testing.
Yes.
But the cons? Man, that seems like a nightmare to maintain. You're maintaining two completely different data schemas. If you add a custom dimension or a new conversion event to the main site, you have to remember to duplicate that exact setup in the internal site too.
It's true.
Plus, for high-traffic sites, you might run into GA4's 10 million event-free tier quota much faster because you're duplicating tracking tags.
It is a significant administrative burden, without question. Dual tagging requires a very mature analytics operations team.
For sure.
But this brings us to the core philosophy of everything we have discussed today. Data integrity is not set and forget. You cannot set up your IP rules once and walk away. It requires active, ongoing hygiene. You should be running monthly checks using the explorations tool in GA4 to ensure the test data filter name dimension isn't showing up where it shouldn't. You need annual or even quarterly reviews with your IT department to verify that the corporate IP ranges and VPN exit nodes haven't changed.
It's just basic digital hygiene. But keeping track of all these moving parts, the testing states, the cookie expirations, the regex rules, is exhausting. Which brings us to the tools that can actually automate this hygiene for you.
Exactly.
Throughout this deep dive, we've seen how complex and incredibly fragile this setup can be. A missed toggle switch, a stale IP address from an old office, a bad regex pattern, any of it can skew your reality and cost your company real money.
Yeah.
This is exactly where tools like GA, which is built by Ninapol, become invaluable for marketing and product teams.
Indeed. An automated GAA fix audit is essentially a daily stress test for everything we've covered today. It automatically checks if your internal traffic rules are actually defined and up to date.
That's huge.
It verifies whether those crucial data filters are sitting in a useless testing mode or are actively protecting your standard reports. It looks for custom parameters that might be interfering with your tagging architecture. It takes the human guesswork and the manual memory out of the equation.
Exactly. If you are listening to this right now and you haven't touched your IP exclusions since you first migrated to GA4 back in 2023 or 2024, you need to assume your rules are stale.
Oh, absolutely.
You need to audit them today, especially before you walk into your next quarterly budget review and ask the CFO for more marketing spend based on acquisition numbers. It might literally just be your own sales team refreshing the homepage. You have to ensure that the reality you're acting on is still trustworthy.
And I want to leave you with one final, slightly uncomfortable thought.
Oh, okay. Let's hear it.
We spend so much time trying to scrub our employees out of the data so we can see the real customers. But consider this. Your own employees, especially those who use your product every day, are effectively your ultimate power users.
Oh, that's true.
They know the fastest paths. They know the shortcuts. If your genuine customers aren't replicating that same deep, efficient engagement, perhaps the bigger question isn't just how to filter the internal noise out.
Right.
The bigger question is, why is there such a massive gap in behavior? If up to 30% of your perceived website growth over the last year was actually just your own team falling in love with your product, how does that change your strategy for tomorrow? Are you measuring success, or are you just measuring yourselves? Are you just filtering out operational noise, or are you filtering out the exact frictionless user behavior your UI team should be trying to teach your actual customers?
Wow. So what does this all mean? It means your internal traffic isn't just a nuisance. It's a benchmark for what product mastery looks like. That is a completely different way to look at the problem. Audit your setup, layer your defenses, and make sure your reality is actually real before you make your next big move. Thanks for joining us on this deep dive. Keep questioning your data, and we will catch you next time.